Looking at the curve below, why is the second derivative negative at the green point and positive at the red point? Hello, welcome back to the Quant Plus YouTube channel. Today, I had a shorter video in mind for you all, and that is a quick discussion on the intuition behind relative maxima and relative minima, at least in a single variable case. You can extend this thinking pattern to the multivariable case, although in the multivariable case, you have saddle points to worry about, which kind of confuses this logic a little bit. Anyways, what I've noticed working with students in their first few times seeing the idea of relative maxima, relative minima, concavity, and so on, they often get their signs confused. And what am I saying? What do I mean by that? They often will remember it incorrectly as, oh, if the first derivative is 0 at some given point and the second derivative is positive, then you should be at a maxima. And that if your first derivative is 0 and your second derivative is negative, then you should be at a minima. And I'm assuming that the connection there is that maximum is large, right? And maximum typically, or in many cases, is a positive value. But that is not correct. So as a refresher, in the single variable case, if you find some critical point C by finding the roots of the first derivative, so setting the first derivative equal to 0 and solving for x in the single variable case, and you find that the second derivative at that critical point that you found is negative, then you're actually at a relative maxima. And if your first derivative is 0 at some given point, so you're at a critical point, and your second derivative is positive, you're actually at a relative minima. Why? Well, let's take the example of a roller coaster. I would imagine many people have ridden a roller coaster at least at one point in their life. And, well, let's say you get on your roller coaster, the roller coaster starts going up a hill, up a hill, up a hill until you reach the top of that first hill. And just for 1 second there, what happens? For 1 second there, you're stopped, right? You're not moving anywhere, and that's indicative of your first derivative being 0. And, well, your maximum is your highest possible point, so the only possible motion that you can have is to get pulled downward. That getting pulled downward, right? That inclination to be pulled towards the center of the earth, if we're thinking about it in terms of the physics context and gravity, that's your second derivative being negative, right? Because you're getting accelerated downwards towards the surface of the earth. Well, if you proceed along in the ride, right? If you proceed along and you're riding, okay, you hit that first hill. Now you dropped and you have that first big hill and you gained a lot of speed. Great, fun, yay, you probably screamed. But the point is that now when you are at that lowest point, right, maybe before the next hill begins or something like that, well, then what happens? Again, for one very brief second, you're going to be stopped in that very bottom of the valley. But now, let's say the track is curved upward and your velocity and momentum is pushing you along that track. So now, even though you're momentarily stopped, the direction of of the motion that you're going to go in the next fraction of a second is upward. And that's an intuitive explanation as to why the second derivative is positive at minimum value, right? At a minima. Because by definition, a maximum is larger than or equal to all the points around it, and a minimum is smaller than or equal to all the points around it. So if the direction of motion indicates that you're going upward, and the only direction that you can go in is upward, that must tell you that you are at the lowest point. And in the same way, if the only direction of motion that can follow is downward, that must mean that you are at your highest point or your maximum. Before we head out for today, thank you again for the support. I'm continuing to see the growth and I really appreciate it. I also appreciate the feedback, so I would love more of that. If you found this content informative, please support the channel. You can do that by liking this video, sharing it with your friends and family, subscribing to the channel, and leaving feedback in the comment section below. And if you're interested in one-on-one tutoring sessions, please follow the link in the description below. Have a great day.